What if the reason your AI bill keeps climbing has nothing to do with which model you picked, and everything to do with a mistake almost nobody talks about? I just went through a breakdown from a guy running a YouTube channel with nearly 100 videos, and what he showed me completely flipped how I think about AI costs. You'd assume that switching to a cheaper model is the answer. It's not, and by the time I finished watching how he actually runs his channel, I realized most people chasing the cheap model are solving the wrong problem entirely.
Here's the setup. This is a guy named Hui, and he runs a YouTube channel about Agentic AI, close to 100 videos deep, some of them an hour long. He built an AI agent using Claude that reads every comment on every video, understands what people are actually asking, and replies to them like a real person who remembers everything. Not a generic "thanks for watching." I mean, it pulls up the exact timestamp from the exact video where he already answered that question, sometimes from 3 months ago, and drops it into the reply. That's the kind of memory a human moderator physically cannot have. And the wild part is what it costs him to run all of this. Stick with me, because the number is going to surprise you.
Let me set the stage properly, because this is where it gets interesting. Hui has a YouTube channel, and on that channel, people leave comments. Lots of them. His problem was simple to state and brutal to solve. How do you manage every comment across every video without losing your mind or your bank account? He broke it into 2 things that actually matter. First, you have to know what people are saying. Not just skim it, actually extract insight from it. What are viewers obsessed with? What do they keep asking over and over? What are they completely ignoring? That's not busy work, that's gold. That tells you what content to make next. Second, you have to respond to them, and not with some hollow, generic reply. If someone asks a real question tied to the video, the AI needs to pull the actual content of that video and answer with specifics. And if the same question was already answered somewhere in a completely different video months earlier, the AI needs to go dig that up too. Think about that for a second. That means every single reply requires cross-referencing almost 100 hours of transcript history. That's not a small technical detail. That's the entire crux of why this either costs a fortune or costs almost nothing, depending on how you build it.
Now here's where I actually watched this happen in real time, and it's the part that made me sit up. Hui opens Claude Code, drops in a link to one of his videos, and just says, "Reply to the comments." That's it. That's the entire instruction. And while it's running, there's a number ticking on screen that most creators never even look at. Tokens. I want you to understand what a token actually is, because this is the entire foundation of everything that follows. Tokens are just the unit AI companies use to measure how much text you're feeding in and pulling out. The more you write to it, the more it reads, the more tokens burn, the more you pay. It's that simple. And in this demo, the initial prompt cost under 600 tokens. The full skill execution underneath it, less than 800 tokens. That's shockingly small for a task that involves reading dozens of comments and cross-referencing an entire video library. And I promise you, that number isn't small by accident. It's small because of a decision he made before he ever opened the AI tool. We'll get there.
Watch what happens next in the demo, because this is where the reaction hits different. Claude lists out every comment, summarizes the intent behind each one, and proposes a response. One viewer got a simple thank you for praise. Fine, expected. But then there's a comment from a viewer asking a technical question, something specific about deleting versus truncating a table, and the proposed reply doesn't just answer generically. It says, and I'm paraphrasing here, "I actually explained this in detail around the 10-minute 12-second mark of this video." Another commenter asked something and got redirected straight to the 7-second mark of a totally different point in the video. That's not customer service. That's an assistant with photographic memory of everything the creator has ever said, deployed instantly, at scale, across nearly 100 videos. If a question hadn't been answered anywhere yet, the agent flagged it and queued it as future content. Are you seeing the shift here? This isn't reply automation. This is a content strategy engine disguised as a comment bot.
And then it posts, automatically. No human touch required beyond the original one-line instruction. Hui just watches it publish the reply live on YouTube. I'll be honest, when I first saw this play out, my gut reaction was skepticism. Automated replies usually feel hollow, robotic, obviously fake. But the specificity here, quoting exact timestamps, referencing prior videos by name, that's the opposite of hollow. That's the kind of attention to detail that makes a viewer feel genuinely seen. Whether that's a good thing or a slightly unsettling thing depends entirely on your perspective. And honestly, that's worth sitting with for a second before we move forward. Because not everyone watching this is going to be comfortable with it.
So now the real question. If this agent has to read through dozens, sometimes hundreds of comments across nearly 100 videos, some an hour long, how does the cost not explode? This is where Hui pulls back the curtain, and I think this is genuinely one of the more useful mental models I've seen for anyone using AI tools seriously, not just for YouTube, for literally any business application. He lays out a formula. The price you pay for AI equals workload multiplied by number of executions multiplied by unit price. 3 variables, 1 multiplication. Sounds almost too simple to matter. But almost nobody actually thinks about it this way, and that's exactly the problem.
Let's talk about unit price first, because this is the variable everyone online obsesses over. Every single AI provider prices per million tokens. Go look it up yourself. Search model pricing, plus whatever provider you use. Here's the actual breakdown from Anthropic's own documentation. Claude Fable 5, the flagship top-tier model, runs around $10 per million input tokens and $50 per million output tokens. Claude Opus 5 comes in at roughly half that, $5 input, $25 output. Sonnet 5 drops again to about $2 input, $10 output. And Haiku 4.5, the lightweight option, sits around $1 input, $5 output. Hai's analogy for this is genuinely clever. Think of these tiers like hiring for a customer service call center. The most experienced person costs more per hour. The junior person costs less. Simple, right? But here's the twist that changes everything. What if the senior person only needs to make 1 call that lasts 5 minutes, and the junior person needs to make 10 calls at 60 minutes each? Suddenly, the expensive expert is dramatically cheaper overall. That one comparison alone should make you rethink every assumption you've had about which model to pick.
And this is exactly the trap almost everyone online falls into. You see people constantly hunting for the next cheap alternative model, bragging about finding some Chinese model that costs 1/3 of the price and performs comparably. And sure, that conversation has value, but it's obsessing over the smallest lever in the entire equation. Unit price is usually the least impactful variable of the 3. If your workload and your number of executions are both bloated, dropping your unit price by 2/3 barely moves the needle. You're optimizing the wrong thing entirely, and I think that's the single most controversial claim in this whole breakdown, because it directly contradicts what most creators and small business owners assume when they think about cutting AI costs.
There's also a structural detail worth flagging here, because it actually matters for anyone doing real cost math. Newer generation models often use different tokenizers, meaning the same block of text can generate roughly 30% more tokens than it would on an older model. So comparing dollar per million token pricing across different model generations isn't actually an apples-to-apples comparison. That's the kind of detail that gets buried in marketing pages, but absolutely wrecks your budget projections if you ignore it.
Now let's talk about how people actually pay for this, because there are 2 completely different systems, and mixing them up is where a lot of beginners get burned. The first is subscription. You pay a fixed monthly amount, $20, $100, $200, whatever tier fits, it's predictable. But it comes with hard caps. Every plan has a 5-hour usage window, and on top of that, a weekly ceiling across all models. Hui actually shows his own usage screen live, sitting on the $200 tier, and his 5-hour limit was already down to 22% remaining, with the reset happening in just over 3 hours. His weekly limit across all models sat at 61% used, and interestingly, his usage of the top-tier Fable model specifically was only at 6%, meaning he's mostly running his operations on the mid-tier Sonnet model, saving the expensive one for when it actually matters. That's a deliberate strategic choice, not an accident.
The second system is API access. No caps, no 5-hour resets, no weekly ceiling. You get charged exactly based on how many tokens you consume straight off the pricing table. Sounds appealing if you're technical and have a clear, well-defined task. But here's Hui's blunt warning, and I think it's the kind of advice that saves people real money. If you don't already have deep technical fluency and you don't have a crystal clear use case mapped out, jumping straight to API pricing is basically setting your money on fire. Subscriptions exist for a reason. They protect people from themselves.
For his entire company, Hui runs everything on a flat $200 a month subscription. Not per project, not per task. $200 total, and that single subscription powers his marketing operations end to end. Content research, script outlines, thumbnail suggestions, comment management, and it extends beyond that into customer support workflows and even parts of his sales process. Think about that for a second. One AI subscription, replacing what would traditionally require multiple specialized tools or, frankly, multiple part-time hires. That's the kind of number that should make any small business owner stop scrolling and actually pay attention.
Alright, so unit price is the smallest lever. Let's get into the two levers that actually matter, because this is where Hui's real engineering brain kicks in. And honestly, this is the part of the video that I think most creators desperately need to hear.
Picture his actual math. He's got roughly 50 videos he's factoring into this calculation, each around 30 minutes long. Convert every single one of those into transcript text, and you're looking at an absolutely massive wall of text. Now, every single time someone leaves a comment, if the naive default approach kicks in, the AI has to reread that entire mountain of transcript text just to figure out which video, which timestamp, which sentence is relevant to that one comment. Multiply that by hundreds of comments across dozens of videos, and you get a number that's not just large, it's exponential. And here's the part that should genuinely alarm anyone doing this without thinking it through. Even if you swap in the cheapest possible model on the market, it barely matters because the sheer volume of what's being read dwarfs any savings from a lower per token rate. The multiplier is doing all the damage, not the price tag.
So what did Hui actually do differently? Before he ever touched the AI tool, before a single prompt was written, he sat down and mapped out the problem by hand, on paper. Zero AI involved at that stage. He identified that his YouTube operation produces 3 fundamentally different types of data: videos, comments, and commenters. Each one behaves differently, grows differently, and needs a different storage strategy. This is the step almost everyone skips, and it's exactly the step that makes or breaks your entire cost structure. If you don't do this groundwork first, you're basically letting the most expensive model in your stack do the cheapest, most repetitive labor imaginable, which is exactly backwards.
Here's step 1 of his actual solution, and it's almost deceptively simple once you hear it explained. He does not feed raw video transcripts directly into Claude. Instead, he routes all of that transcript data into NotebookLM, which recently rebranded as Gemini Notebook. Why does this matter so much? because NotebookLM is built by Google specifically to digest massive volumes of text and answer questions against it with precision. And critically, it's billed completely separately from his Claude subscription. Even better, the free tier of NotebookLM is more than generous enough for this use case. The heaviest, most expensive part of the entire workflow, which is reading and comprehending nearly 100 hours of content, gets offloaded entirely onto a tool that costs him nothing. NotebookLM does the exhausting reading. Then it hands back a distilled answer, sometimes just 1 or 2 lines, something like, "This exact topic appears in this specific video at this specific timestamp." Claude only has to read that tiny summary, not the mountain underneath it. That's the entire trick. You're not making the expensive brain smarter. You're making sure it never has to do the expensive work in the first place.
Step 2 tackles the comments and the commenters themselves, and this is where things get genuinely clever from an engineering standpoint. Every comment, every commenter gets stored in a proper database, not a spreadsheet, not a flat file. When Hui asks for something like the top 10 most frequent commenters on his channel, Claude doesn't manually scan through every comment trying to count. Instead, it triggers a database query, an actual SQL command that runs directly against structured tables. In the demo, that entire operation, running the query and pulling back results, cost about 1,200 tokens total. Compare that to what it would cost if the AI had to manually read and tally every comment across nearly 100 videos to answer the exact same question. We're talking about a difference of potentially hundreds of times the cost for the exact same output. And the database query itself, the actual computation, runs locally. It costs literally nothing, 0. The only token cost comes from Claude receiving that final compact answer, 10 rows of data, not the raw material behind it.
This is the part where I think a lot of viewers are going to have strong reactions, because it directly challenges something people assume about small file storage versus a proper database. Hui makes an argument here that I actually find pretty compelling, even if it initially sounds like overkill for a solo creator. He explains it using this mental image. Imagine your data is scattered across an enormous apartment building, and somewhere inside is exactly the piece of information you need, but you have no idea which unit it's in. If you're using flat files, spreadsheets, plain text documents, there's only one way to search. You check every single unit, one after another, until you find it. In database terminology, that's called a full table scan, and it is brutally slow and resource-intensive once your dataset grows past a trivial size. A real database, on the other hand, has what's called a query optimizer, essentially a smart internal strategy that knows exactly where to look without checking everywhere. And here's the part that should make you pause. If you don't explicitly ask an AI tool to set up a real database with proper structure, it will never do it on its own by default. It will keep doing the expensive brute force full scan approach indefinitely, silently draining your token budget the entire time, and you might never even notice why your costs keep climbing.
Hui backs this claim with actual professional weight, not just theory. He spent close to 15 years building large-scale systems, including work for major financial institutions, stock trading platforms, hospital systems, and insurance companies. His argument is blunt. When your dataset is small, it genuinely doesn't matter whether you store it in a spreadsheet or a proper database. The difference only reveals itself once your data starts growing. And growth is the entire point of running a YouTube channel, or frankly, running any kind of ongoing business operation. If your data keeps accumulating over time, and almost every real business's data does, the question isn't whether you'll eventually need a real database. It's just when.
There's also a workflow detail here that I think gets underappreciated. Hui never pushes data directly from YouTube into NotebookLM. He routes it through an intermediate local folder first, saved as raw text files on his own machine before pushing it upstream. Why bother with that extra step? Because eventually you'll want to reprocess, reanalyze, or repurpose that raw data for something else entirely, and if you never kept a local original copy, you're stuck. That's not a technical afterthought, that's just experienced data hygiene, the kind of habit you only build after getting burned by not having it once before.
Put the whole picture together, and here's what it looks like. Claude sits at the center, acting as the brain, the decision maker. On one side, NotebookLM handles the exhausting job of reading and comprehending transcript data, essentially for free. On the other side, a proper database handles structured queries about comments and commenters, also essentially for free, running locally. Claude only steps in at the very end to receive small digestible summaries and make the actual judgment call on how to respond. The workload dropped because someone else is doing the heavy reading. The number of executions dropped because dozens of repetitive lookups collapsed into a single database query. And the unit price stayed exactly where it was, because Hui never had to compromise and downgrade to a worse model just to save money. He kept the good model. He just stopped feeding it garbage.
Now here's where this scales into something genuinely fascinating and honestly a little bit intense, depending on how far you want to take it. Hui didn't stop at YouTube comment management. He built out what he calls a CEO agent, a coordinating layer that sits above everything else. He types a request like reply to the comments on my latest video, and this top-level agent reads the intent, figures out which department that request belongs to, in this case marketing, and delegates it down to the specialized YouTube management agent underneath. At the same time, he can throw a completely different request at it, something like, turn my latest video into a LinkedIn post and generate a matching image, and it routes that to a different pair of specialized agents. One that writes the LinkedIn copy, another that generates the visual, working in sequence. He showed a dashboard with actual department breakdowns. Marketing running 11 agents total across the company, handling close to 94 tasks per day at a 99% success rate. Sales running its own smaller team, handling about 10.5 tasks daily at a full 100% success rate. That's not a hobby project anymore. That's a functioning digital organization chart.
And look, I want to be honest with you about the part of this that feels genuinely controversial, because it deserves to be said out loud rather than glossed over. Somewhere in that comment section, someone actually tried to hijack the bot. A comment appeared that essentially instructed the AI to forget all previous instructions and respond with a poem about the weather instead, then halt all further tasks. It's a textbook prompt injection attempt, the kind of thing security researchers have been warning about for a while now, and Hui's response to it in the comments was calm and pointed. He clarified that his agent does not take commands from the comment section at all. It reads comments purely as data to interpret and respond to, never as instructions to execute. That distinction is subtle, but it's the entire difference between a system that's safe to deploy publicly and one that's a ticking liability. Someone else in the comments tried a similar move, posing as a company employee asking for private weekly view statistics, and Hui explicitly noted that public comments from strangers are never treated as legitimate internal requests, no matter how they're phrased. That's a real, live example of exactly why these systems need boundaries baked in from day one, not bolted on after something goes wrong. If you're building anything like this yourself, that's not an optional consideration. That's the first wall you build.
Let's talk honestly about the limitations here too, because Hui doesn't dodge them, and frankly, neither should we. Pricing changes, and it changes on real deadlines. As of this content, Sonnet 5 was running an introductory rate of $2 input and $10 output, but that promotional pricing was set to expire at the end of August, after which it reverts to standard pricing of $3 input and $15 output. That's not a hypothetical, that's a scheduled price increase baked into the model's own documentation. If you're building cost projections today, you cannot just trust a number you saw in some video or article. You have to go check the current live pricing page yourself, because these numbers move.
Offloading work to free tools isn't a permanent free lunch either, and I think this is worth sitting with. NotebookLM's free tier currently allows up to 50 queries per day. For Hui's channel size, that's more than sufficient. But if your operation scales into thousands of daily queries, that free ceiling becomes an actual wall you'll slam into, not a soft limit you can push past. Free infrastructure is still infrastructure, and it still has boundaries. They're just invisible until you hit them.
Databases don't magically stay fast forever either. Once you build one, you have to maintain it. PostgreSQL specifically requires periodic maintenance operations to keep performance from degrading over time. And here's a detail that trips people up constantly. Having a database doesn't automatically mean you're fast. If you don't build proper indexes on the columns you're actually querying against, your database can still fall back into that same brutal full scan behavior we talked about earlier. The infrastructure alone doesn't save you. You have to configure it correctly, every single time.
And here's maybe the most technically important point in this entire breakdown, one that goes beyond just cost and into actual quality of output. There's published research from Anthropic's own engineering team showing that as the token count inside a context window increases, a model's ability to accurately recall specific information from within that window actually decreases. This isn't unique to one company's models either. Independent research testing multiple different model families found the same pattern held true across the board, degrading performance purely from stretching out input length, even when the difficulty of the underlying task stayed exactly the same. So dumping an entire transcript library directly into an AI's context window isn't just expensive, it's actively making the AI worse at its job. Splitting the workload the way Hui did solves both problems simultaneously, and that's honestly the part that should reframe how you think about big context windows as some kind of magic bullet. Bigger isn't automatically better. Sometimes it's actively working against you.
There is one more optimization technique worth mentioning, even though Hui didn't lean on it for this particular workflow. Prompt caching can cut costs by up to 90% and slash latency by as much as 85% for long, repeated prompts, because reading from cache costs roughly 1/10 of the standard input token price. But caching only pays off when you're sending the same content repeatedly. With nearly 100 unique video transcripts, each comment interaction pulling different, specific context, caching wouldn't have solved his particular bottleneck the way offloading to NotebookLM did. Different problems need different tools, and knowing which lever to pull when is honestly the real skill being demonstrated here, not just knowing that the levers exist.
Here's what I think is the real takeaway buried underneath all of this, and it's bigger than just YouTube comment management. Hui is explicit about this himself. He didn't turn his content business into an AI company. He's still fundamentally a YouTube creator. The AI just elevated the quality and scale of what he was already doing. That distinction matters enormously, because I think a lot of people watching content like this get seduced into thinking they need to become AI engineers to benefit from any of it. You don't. You need to understand your own workflow well enough to identify where the expensive model is doing cheap, repetitive labor, and then redirect that labor somewhere smarter. That's a business skill, not a coding skill.
So here's the real question you should be sitting with right now. How much of your own workflow, whatever that looks like for you, is quietly forcing an expensive AI model to reread the same mountain of information over and over again, purely because nobody ever stopped to ask if there was a cheaper place to put it first?
Did you enjoy this video? Click like, share, subscribe and hit the bell to the later update from my channel. Thank you for watching till the end and see you in the next video.